A very good evening, one and all. Last class, we discussed about the introduction of the discrete Fourier transform, and we discussed some properties which is including in DFT. And today we will discuss the concept called the remaining properties what we have, which is related to discrete Fourier transform. And then we will see the properties of also, and we will see the properties also with along with the proofs and all. And at the end of the session you will able to learn what is the properties we have, how we can solve these all properties, along with we will discuss. And at the end of the session you will able to learn the concept of DFT. Already we learned DFT concept, and these are the summary of properties what we have: linearity, time shifting, frequency shifting, and modulation. But all properties we have in previous session. Previously, we learned two properties along with the statement and proof. One is the periodicity property, second one is the linearity property. And then third one we will, and also time shifting property also we done. Now the property name, fourth property is, so now coming to the fourth property, I will take. So now coming to the fourth property, it is circular circular frequency shifting. Circular frequency shifting. So first and foremost, what we already studied. First, we have the x of n. Then apply x of n to the DFT. Then you will get the x of k. So it is the frequency and it is the time. Now the concept is called frequency shifting. Means I can shifting frequency with respect to some variable that is the constant. Then I will get x of n, x of n e to the power of e to the power of j 2 pi, where we can write it as a k. Here we can replace k with the n and along with n and n. Now the term is called circular. Circular is nothing but is simply you can take the two brackets along with your n. So while applying to this term DFT, you will get the x of k minus n. Now let's coming to the proof point of view. We know the x of k, where x of k is equal to summation n is equal to some 0 to n minus 1 x of n e to the power of minus j 2 pi k n by n. This is the formula, we know that. Now replace k equal to k minus l, because of we know that x of k minus l is equal to replace k with the n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi, replace k with the minus k minus n. Now segregate this term, n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi k n by n into e to the power of j 2 pi l n by n. And already we know that what is this term? This is nothing but a x of k. This is nothing but x of k into e to the power of j 2 pi l n by n. Now simply x of k, and that is nothing but you can write it as a DFT of x of n e to the power of j 2 pi ln by n. So that is nothing but a circular interval of x of n. So it is the term we have to be learned, right? So this is the property. The next coming property, which is also related to time reversal. Time reversal, circular convolution. We just turn the next property, time reversal. So time reversal is nothing but a simply where I will take, we know that x of n, you can apply the Dft. You will get the x of k, right? You will get the x of k. Now the concept is called Dft of what I have to do, time reversal, that is the x of minus n. And we know that it is simply, x of some capital N minus n. It is nothing but simply, which is nothing but a what? Which is nothing but a x of minus k of n. That is nothing but a x of n minus k. This is the, we need to be go for the proof. While we can go for the proof, first and foremost, you have to take the dft of x of n minus n. I just take the dft of x of n minus n. That is nothing but a summation n is equal to 0 to n minus 1, where x of n minus n e to the power of minus j 2 pi. You just keep in your mind, it is that x of n minus n I will take. I will not to take x of 2 pi. I will not replace n with the n minus 1. Here I just take the x of n. So this is the term I can take. Now replace n minus n is equal to m. Then n is equal to what? N minus m. So if you substitute lower limit n is equal to 0, then m is equal to n. Then substitute n is equal to n minus 1, where you will get m is equal to 1. With this all the terms, I will get x of n minus n. This is the DFT. It is nothing but what? Summation m equal to capital N to n x of m e to the power of minus j 2 pi k n minus m by n. This is the term I will get. Now the term, we can interchange the some summations, all that you will get what? Summation m is equal to some n minus 1. I just take it as a, if the term will be including 1 to n, now I will take the previous values also. That will not to be changed anything. So that will maybe 0. We don't have any issue. E to the power of j 2 pi k m by n e to the power of minus j 2 pi k n by n. And of course, we know that it is the, the term is called 1. Now I can write it as a summation m equal to 0 to n minus 1 x of m e to the power of j 2 pi k m by n. Now I replace to write it as a e to the power of j 2 pi by n. I just replace k with the m. Of course, any term will be equal to 1. So simple, I can write it as a summation m is equal to n minus 1 x of m. So I just aggregated e to the power of j 2 pi by n minus k into m. So it is nothing but what? X of n minus k. So it is the term, we can write it as the property. right? Next we have circular property, circular convolution, multiplication or modulation property, and then Parseval's theorem. So third property, so circular property, we will statement here I express. Next class we will discuss the circular convolution. And we know the statement. We going for statement. Statement is that V multiplication of two time signals x1 of 2 and x2 of n. Simply, of course we know that dft of x1 of n. We know that that is nothing but x1 of k, and dft of x2 of n, that is nothing but a x2 of k. Likewise, we can take if you multiply these two signals. While I will take, if I will take it as a y of n, and of course dy of t y of n it is nothing but a y of k. Now coming to that statement, dft of y of n, so that is nothing but a product of two signals x1 of n and x2 of n. It is nothing but a what? Y of k, where y of k is nothing but a x1 of k into x2 of k. So the here we can take the not multiplication, convolution, where we can write as a convolution like that. We can circular convolution means we can write it as a n in circular. So finally what? Time convolution means it is the time convolution. So that is the finally what you will get, x1 of k into x2 of k. So finally what statement you will get from this property is nothing but convolution. So you have to keep in your mind, convolution in one domain is nothing but a multiplication in other domain, right? So by next class we will discuss the property of statement, and with this you will get what is the IDFT formula, state and prove any four properties, like that last time also same questions you will get. So we will discuss the properties of next three and